welcome my dear students. This is the class on right relations, and we are going to discuss some different kinds of problems on this relation to get more clarity on different kinds of problems. On part of this, the first problem, which are all from your material only, you have to identify, but I am writing in a sequential way. These are all okay, your IIT material, right? From them only we are discussing like this. Let R be a relation in N defined by x plus 2y equal to 6. Then find number 1, domain of R, range of R inverse. You see my dear students, first of all, this relation, how the relation is defined, x related to y, right? X plus 2y equal to 6. This is the relation connecting x and y like this, right? Okay, where x belongs to n and y belongs to n, natural numbers, both are. Okay, this is a relation from, actually this is a relation in n means n to n like this, right? Natural numbers to natural numbers. That means R is subset of n cross n here. R is subset of n cross n like this. Now, if you take x plus 2y equal to 6 like this, my dear students, we need all natural numbers of this. Okay, what we do is x plus 2y equal to 6, this is equal to, from this 2y is equal to 6 minus x, like this. And from this we have y is equal to 6 minus x by 2, like this. Y is equal to 6 minus x by 2. Now let us correct all the numbers such that we should get x is a natural number and y is a natural number, where both x belongs to n and y belongs to n. Such type of things we are going to discuss. Now if I take for example, okay, x is equal to 1, right? Okay, fine. You see here, if I take x is equal to 1, I am going to x is equal to 1 if I take y is equal to 6 minus 1 by 2, that is 5 by 2. Okay, 5 by 2 is not belongs to natural number, therefore this ordered pair we will not take like this. Next I will take x is equal to 2, y is equal to, right my dear students, 6 minus 2 by 2, that means actually 4 by 2. 4 by 2 is nothing but 2. Therefore we have got nicely one ordered pair 2 comma 2, right? Both are natural numbers, no doubt in it, of course. Now if you take x is equal to 3, x is equal to 3 you will not get, okay? Y equal to 6 minus 3 by 2, you will not get. 3 by 2 does not belong to natural numbers. When you take x is equal to 4, y is equal to 6 minus 4 by 2, like this, right? That is nothing but you will have 2 by 2, that is 1, like this. That means both are natural numbers, you have one nice ordered pair 4 comma 1. In the same way, x is equal to 5 will not satisfy, 1 by 2 you will get. X equal to 6, if you take 6 minus 6, 0 by 2, 0 is not a natural number. Therefore we have only, though the relation is having, my dear students, the relation is having, right, only two ordered pairs. One is 2 comma 2, right, and another one 4 comma 1, like this. The another one what we have here like this, 4 comma 1, like this. Wonderful. See, this is the relation what we have here. Now we need domain and range of R like this. Now if you write this relation like this, right, 2 comma 2 like this, and 4 comma 1 like this, if I write, right, this is what we told us the domain, right, and range. Okay, this is what we have got, the range also. Now the domain is nothing but, my dear students, here what we have got, domain of this R is 2 comma 4 like this. 2 comma 4, domain of R is nothing but 2 comma 4, and range is nothing but here, range is equal to, you have 2 comma 1, they are all the related elements with the 2 and 4 like this. And the third one, okay, domain we got, the first one we have got now like nicely, second one we got, now the third one is nothing but R inverse. R inverse, we know that just the reciprocal of, okay, you just interchange these elements, 2 comma 2, if you interchange you will get once again 2 comma 2 like this, and 4 comma 1, if you interchange you will get that 1 comma 4 like this, 1 comma 4. That's what, in this way you will be doing this particular problem, my dear students, right? Fine. Now see, my dear students, this problem, the second problem what we have here, you let A is equal to 2, 3, 4, 5 and R is equal to 2, 3, 2, 4, 2, 2, 3, 3, 3, 4, 3, 5, 4, 4, 5, 2. Like this. Is R reflexive? Explain. If R is reflexive means, my dear students, we told you already. What we told is every element should be related to itself according to the given relation, right? We should have 2, 2. 2, 2 is there, yes, 2, 2 is there here, of course. 3, 3. 3, 3 should be there. 3, 3 will be there in this. 4, 4. 4, 4 also there. 5, 5 should be there. But 5, 5 is not present in this, right? 5, 5 should also present within this. 5, 5 is not present within this, of course. Okay, 5, comma 5 also should belongs to R. Then only we can say that it is reflexive. Otherwise, it is not reflexive. Okay, understood, my dear students? Why it is not reflexive? You should have what? Actually, you should have 2, 2, right? 3, 3, next 4, 4, 5, 5. Okay, after that, any elements beyond this. Okay, apart from this, you can have 2, 3, 2, 4, right? 3, 4, 3, 5, right? 5, 2, like this, so on you can have. But basically, if it becomes to be reflexive, you should have 2, 2, 3, 3, 4, 4, 5, 5. Here 5, 5 is missing, that's why it is not reflexive, right? Fine, right, my dear students? Now see, my dear students, this third problem, n is equal to 1, 2, 3, so on up to infinity let. Which of the following relations n in n and n cross n, we are going to take R is from n, R is subset of n cross n, are symmetric, are transitive, are reflexive? That is what our nice question here. Okay, they given these 4 relations here. A, okay, is A satisfying symmetric, transitive or reflexive, right? Or like this, we need to check these 3, we have to check. Okay, well, let us check from reflexive, symmetric and transitive, right, my dear students? You see here, the first one, A is greater than equal to y, x plus y equal to 6, x is a multiple of y, 3x plus y is equal to 5, like this we have here. Let us take now, my dear students, here what we have here, x is related to y. Here, how it is, we are having x is greater than or equal to y, like this. X, first one, okay. Now, let us check that whether it is reflexive first. If you check that whether it is reflexive. Reflexive means what? X should related to x. Can you say that x greater than or equal to x? Okay, x greater than or equal to x means x equal to x is one part of this. Is it true or false? It is true. Why it is true? X greater than or equal to, every number is greater than or equal to x is true. If you say that only x greater than x, this is false. But when you say that when x is greater than or equal to x means it is true, because equal option is there, that's why it is possible, right? Therefore, it satisfies reflexive property. Okay, the first one, A, what we are having is here, that satisfies the reflexive property. It satisfies reflexive property. Next, we will take symmetric, right? Whether it satisfies symmetric or not. Symmetric means, you know, my dear student, x related to y. If x related to y, then we should prove that y related to x. We should prove that y related to x. If x related to y means, what is the meaning here? Of course, x is greater than or equal to y. Okay, y related to x means, can you say that, right? If x is greater than or equal to y, can you say that y is greater than or equal to x? Okay, always is it possible, right? If x greater than or equal to y, can you say that always y greater than or equal to x? That is not possible like that, right? For example, we say that 2 is greater than or equal to, right? Okay, otherwise you take some number, 3 greater than or equal to 2. That is true. Okay, can you say that 2 is greater than or equal to 3? That you cannot say like that, right? Therefore, it not satisfies symmetric. It won't satisfy symmetric, right? Very good. Next, transitive. Okay, transitive. If you take here in this, if you take transitive here, of course, because 3 problems I combinedly explaining here in this one particular problem here, of course. Transitive means what here? If x related to y, y related to z, then x related to z. This is what we have here like this. X related to y, y related to z, then we should prove that x related to z. Here x related to y means what? X related to y means what, Nana, here? Fine, let us see that. X greater than or equal to y, right? and y related to z means what here? Y greater than or equal to z, like this, right? Now we see using these two, x is greater than or equal to y and y is greater than or equal to z. From this, can't you say that x is greater than or equal to z? Yes, we can say that means x is related to z. That is true. Therefore, transitive is satisfying. Therefore, this x greater than or equal to y, my dear students, it is satisfying reflexive transitive, but not satisfying symmetric. Like this, this beautiful problem can be understood. Like, see the next one, what we have here, the second one, x related to y. X related to y means here x plus y equal to 6. This is the relation. X and y are connected by the relation x plus y is equal to 6, like this. Okay, wonderful. Now let us check whether it satisfies reflexive. Okay, the first one, reflexive. Reflexive means, my dear students, here, okay, let us check that whether it satisfies reflexive property or not. X is related to x, right? X is related to x means, can we say that x plus x is equal to 6? That means what? 2x is equal to 6. That means x is equal to 6 by 2. That means x is equal to 3. When x is equal to 3 only, we will get, right? When x is equal to 3, we will get x plus y is equal to 6. Okay, we have got only when x is 3. Okay, 3 related to 3. That means 3 plus 3 equal to 6. Then only it satisfies. If you take some other number, suppose 2 related to 2, then you will get 2 plus 2 is equal to 4 only, but it is not 6. Therefore, reflexive property is not satisfying. It is satisfying only for 3. It is because the relation is on n. N means set of all natural numbers. Okay, it should satisfy for each and every natural number. Therefore, reflexive property is not satisfying here. Now, the second one is what? Symmetric, right? Symmetric. If you take symmetric here, my dear students, what you have here is if x is related to y, then we should prove that y related to x here. X is related to y means what? X is related to y means, right, x plus y is equal to 6. If x plus y equal to 6, can't we write that y plus x equal to 6? X plus y and y plus x both are same, commutative property satisfying. That means y related to x, right? Y plus x equal to 6 is true. Okay, if x is related to y, then we can say that y related to x, that is true. That, okay, now like that we have, now the third one is transitive, like this. Let us see how we are going to say this is transitive or not, like this, right? You see, my dear students, transitive, how we will say is, transitive means what? Actually we have here, if x related to y, y related to z, then we should prove that x related to z, like this, right? Okay, fine. Now see, Nana, how we are going to do that is, x related to y means x plus y equal to 6. Y related to z means y plus z equal to 6. Using these two, can we say that x plus z equal to 6? That is what our thing here, of course. You see, my dear students, how is we can say that x plus z is equal to 6? Let us see that actually. Yeah, x is equal to 6 minus y and z is equal to 6 minus y. X plus z is equal to 6, we have to say. Okay, x plus z we have to get 6. That means 6 minus y plus 6 minus y, like this. 12 minus 2y, like this. But we need to get x plus z equal to 6. But we got 12 minus 2y. Therefore, it is not satisfying the transitive property. It is not satisfying the transitive property. Now see, the third one, x is related to y. Here the relation is x is a multiple of y, right? X is related to y means x is a multiple of y, right? Is it true or not? Let us see. First, reflexive, right? Reflexive. Reflexive means what? X related to x. That means x is a multiple of x. Every number is a multiple of itself. Okay, x is a multiple of x. That is true. Okay, every number is a multiple of x. 2 is a multiple of 2. 3 is a multiple of 3. Therefore, it is satisfying reflexive property. Number 2, symmetric, right? Symmetric. Let us see that symmetric will satisfy or not. Symmetric means what? If x related to y, then we should prove that y related to x, like this. Okay, x related to y, that means what? X related to y means what? X is a multiple of y. If x is a multiple of y, can you say that y is a, okay, now y related to x, right? Y is a multiple of x. Y is a multiple of x, like this. If x is a multiple of y, then can you say that y is a multiple of x? If 2 is a multiple, see here, if 8 is a multiple of 2, then we can say that 2 is a multiple of 8? No, you cannot say. Therefore, here, see here, symmetric is not satisfying, like this. Number 3, we have here transitive, like this. Number 3, we have here transitive. See the transitive property, okay, how we are going to prove is x is related to y. You know, x is related to y. If x is related to y, y related to z, then we should prove that x is related to z, like this. Right? X is related to y means, you see my dear students, x is a multiple of y. X is a multiple of y means x is equal to some ky I can write. X is a multiple of y. That means x is equal to ky. Y related to z means y is a multiple of z. That means y is equal to some k dash z we can write. Right? After writing like this, my dear students, now you see, I want to prove that x is related to z. That means x is equal to, you have here ky and that equal to y, k into y. Y is nothing but k dash z, like this. Now x is equal to k into k dash z, like this. Right? That means x is equal to some k double dash z. X is a multiple of now z. Okay, that k double dash is some constant what we have here, like x is a multiple of z we have got, nana. That means x is related to, that means x is related to z, that is true. Therefore it is satisfying transitive. Therefore the relation x related to y, x is a multiple of y, is reflexive but not symmetric, but it is satisfying transitive. It is satisfying transitive, right? Now we have d, this is what, 3x plus y is equal to 5, d. Okay, x is related to y means 3x plus y is equal to 5, like this, right, my dear students? Here let us see that whether it is reflexive or not, whether it is reflexive or not here. Okay, the first one, that means what, x should related to x. That means what we are going to have, okay, 3x plus x is equal to 5. That means 4x is equal to 5. That means x is equal to 5 by 4, right? Here x is equal to 5 by 4 is not at all a natural number and it is not satisfied for any natural number at all. Therefore it is not satisfying reflexive at all, right? X related to x means x is equal to 5 by 4 and it is not a natural number, therefore it is not satisfying reflexive. Number 2, symmetric. Let us see symmetric, will it satisfy symmetric or not. Here see, x related to y mean 3x plus y is equal to 5, right? Fine. If x related to y, then what we should prove? Y related to x. Now you take y related to x. Y related to x means 3y plus x equal to 5. If any equation having 3x plus y is equal to 5, can you say that 3y plus x equal to 5? No. Okay, you cannot say that. For example, I am telling you here, 3 into x, x is 1, you take y is 2. 3 into 1 plus 2 equal to 5. That means here x is 1, y is 2. Now can you say that 3y plus x equal to 5? 3 into y, y is what? 2 plus x is 1. That is equal to what you are getting? 7. But it is not equal to 5. Therefore it is not symmetric. It is not reflexive. It is not symmetric also, like this. Similarly, we can easily say that transitive also it won't satisfy. You see here, transitive what we have here, like this. That means if x related to y, y related to z, then what we should prove? X related to z. X related to y means, my dear students, what we have here. X related to y means what? 3x plus y is equal to 5. Y related to z, y related to z means what we can say is, right, 3x plus y is equal to 5, and y related to z, y related to z is nothing but what? 3y plus z is equal to 5, like this, right? Fine. From using these two, can you say that x is related to z? That means here 3x plus y equal to 5, 3y plus z equal to 5. Now this is now 3x plus y is equal to 3y plus z, like this, because both are equal to 5 like this. Now from this what I can say, right my dear students, 3x is equal to y if we transfer that side, 2y plus z like this. I cannot say that okay here we will not getting anything like 3x plus y equal to something I have to get 5. It won't satisfy at all like this. It is not at all possible and it is not satisfying. Therefore this relation is not reflexive, not symmetric, not transitive. Which one? If x related to y means 3x plus y is equal to 5, right? Now see, we have another important problem. See here, prove or disprove. Either you prove or disprove. If a relation R is transitive, then R inverse is also transitive, right? When R is transitive, see here, when R is transitive, if x is related to y, y related to z, then x should related to z like this. Then x should related to z. This is then only, this is what transitive relation, right? That means what we have here, x comma y belongs to, okay, R, and y comma z belongs to R, then, right, then what we have here is x comma z belongs to R like this. X comma z belongs to R. This is what we have here. Transitive means right? Fine. Now R is having all these elements like this. Okay. Prove if R is transitive. R is transitive means now R is transitive now. That means what we have here, x comma y you are having, y comma z you are having, and x comma z also you are having. This is what R now. Now let us take R inverse. Here it is transitive. X comma y comma z, x comma z is there, right? Now let us take R inverse. R inverse means what? X comma y become y comma x, z comma y, z comma x. Here see, is it transitive R inverse? We have here, my dear student, z is related with x. X is not related with anything here, of course. Y with x, and x is not at all related here, of course, right? Therefore, you cannot say that R inverse is transitive, like, okay? You cannot say that. Now, we can say that, of course, y related with x, right? Or z related with y related with x, right? You can say here nicely, z related with y, z related with x, z related with y related with x, then z related with x like this. See here, z comma y comma x, how the link, and z related with x. That implies what we have got, okay, the relation R inverse, what we have here, zy, yx, zx. R inverse is transitive like this, right? In this way we will be having nicely. We proved that R inverse is transitive, right? See, my dear student, now this problem in JEE mains, they have given that 1 and 2 both combinedly I have written. Okay, find domain and range of this particular problem like this. You see, x is related to y such that x plus 2y equal to 10. This is the relation they are having here. X is a natural number and y is a natural number. And this is a actually this is a relation from natural numbers to natural numbers. That means R is subset of n cross n. That means find domain and range for this. You see, Nana, how we are going to do this is now 2y equal to 10 minus x and y is equal to 10 minus x by 2 like this, right? Where x belongs to n and y belongs to n like this. Suppose you take x equal to 1, x equal to 1, y is equal to what you will have. X you cannot take negative numbers. 0 also you cannot take because both are natural numbers. Y is equal to now 10 minus 1 by 2, that is now 9 by 2. That is not a natural number here. X equal to 2 you take, y is equal to 10 minus 2 by 2, that is 8 by 2, that equal to 4. 4 is a natural number. Now x equal to 3 you take, 10 minus 3 by 2, right, 7 by 2. This is not a natural number. X equal to 4 you take, now y is equal to 10 minus 4 by 2, right, Nana, this is 6 by 2, that equal to 3. 3 is a natural number. Right, in this way, now you take x equal to 5, y is equal to 10 minus 5 by 2, that equal to 5 by 2, that is not a natural number like this. Now you take x equal to 6, y is equal to 10 minus 6 by 2, that is what, 4 by 2, 4 by 2 is 2, okay, this is a natural number like this we have. Now in the same way we take x is equal to 7, right, you will have y is equal to what here? If you take x is equal to 7, y is equal to 10 minus 10, 7 by 2. That is 3 by 2. This is not a natural number. You take now x equal to 8. Y is equal to 10 minus 8 by 2. That is 2 by 2. That is 1. Now you take x equal to 9. Y equal to 10 minus 9 by 2. That is 1 by 2. This is not a natural number. Therefore, all the relations what you have got here are r is equal to, my dear students, here you got one is what? X2 means y4. 2 comma 4. Okay, nicely 2 comma 4. Next 4 comma 3, like this. 4 comma 3. This one 4 comma 3. Next 6 comma 2, like this. 6 comma 2, like this. Next 8 comma 1, like this. Wonderfully we have got. Now for this relation domain. Domain is nothing but the first coordinates. Domain is what? First coordinates. 2, 4, 6, 8. This is what domain. And range is nothing but range is the second coordinate elements. 4, 3, 2, 1, like this. The domain is that and range is this. In such a beautiful way you will be finding the domain and range of this. The domain we have got now 2, 4, 6, right? And the range is you have got 1, 2, 3, 4, like this, right? In this beautiful way you will be doing this particular problem. Now see, my dear students, another interesting problem, which is the sixth one, a relation pi. Okay, they just named as pi. Pi is a relation from complex numbers to real numbers. Is defined by, okay, x pi y means x is related to y by the symbol pi. We can use any symbol. Generally we use r. Okay, already r is used here. That's why they used some different symbol here. Okay, how they related modulus of x equal to y. Then which one is correct? They given 4 options, A, B, C, D. Now let us take A. Okay, here x pi y means, once again I am writing modulus of x equal to y here. X means here 2 plus 3i. 2 plus 3i related with 13 like. Now in this, my dear students, modulus of x. X means here x is 2 plus 3i, y is this. Modulus of 2 plus 3i, that is nothing but the modulus of a complex number is nothing but this is the formula. Modulus of a plus ib equal to square root of a square plus b square. A square plus b square, that means 3 square. Square root of now 4 plus 9, that equal to root 13 is what you have here like this, right? Wonderful. Next, okay, root 13. Now, can you say that here, modulus of x is equal to here y, modulus of x, you have got it as root 13 and y is equal to 13. Now, can you say that modulus of x equal to y? No, you cannot say. Okay, fine. This is option A is wrong. Now, B, you are having here like this. Right, what is B is 3 pi of minus 3, like this. 3 pi of minus 3, right? How you are going to do this 3 pi of minus 3, like, right? My dear students, you see here how we are going to prove this one, right? This is modulus of 3, right? Here x is this, y is this, modulus of 3 is 3, right? Now, can you say that modulus of 3 equal to 3 is equal to minus 3? No, you cannot say like this. Right? Modulus of 3 equal to minus 3. Is it true? No. Therefore, this is also not satisfying. Like that. Next, C. Okay, C is what you have here. 1 plus I pi. 1 plus I pi 2, like this. 1 plus I means what, Nana? Okay, the square root modulus of 1 plus I should equal to 2. Now let us check. Modulus of 1 plus I is nothing but what? 1 square plus 1 square. Is it equal? Okay, that equal to root 2, right? Okay, now root 2 is equal to 2. You cannot say root 2 is not equal to, because the modulus of 1 plus I is root 2. Root 2, okay, this is what x. Okay, x is this and y is this. Root 2 will not be equal to 2. That's why it is not satisfying. Even option C is not satisfying like this. Next, D, what you have here is I pi 1, like this. I pi 1. I means here x is I and y is 1, like this. Modulus of I should equal to 1. That means square root of 1 square is equal to 1. That is 1 equal to 1. This is true. Therefore, option number D is correct in this. right? See this seventh problem. Given the relation R is equal to 1 comma 2 2 comma 3 on set A 1 2 3, then find the minimum number of ordered pairs which can be added to R to make it an equivalence relation. See my dear students, this is the problem we have here. How we will be doing now? You see, they given only R 1 comma 2 2 comma 3. Now okay, on set A 1 2 3, now R is a relation from set A to A. That means R is subset of A cross A, like this, right? That means fine. Now we have R to make it an equivalence relation. Equivalence relation means it should satisfy reflexive, symmetric and transitive. Now they given that 1 comma 2 and 2 comma 3. To make it reflexive, every element should relate it to itself. That means we should have 1 comma 1, we should have 2 comma 2, we should have 3 comma 3, we should have, like this, right? Now it is reflexive. But to make it symmetric means 1 comma 2 is there, then if 1 comma 2 is there, 2 comma 1 should be there. That means 2 comma 1 should be there. Next, if 2 comma 3 is there, 3 comma 2 compulsorily should be there. Then only it becomes symmetric. Now here it is reflexive, symmetric. 1 comma 2 is there, 2 comma 1 is there. Okay, symmetric. 2 comma 3 is there, 3 comma 2 is there. It is symmetric. Now transitive. Now let us see that 1 2 2 3 is there, but we should have 1 3. Here 1 2, x related to y related to z, then x should related to z. That means 1 3 should be there, right? 1 2 is there, 2 3 is there, then 1 3 should be there. Then only it become transitive. That's why 1 comma 3 is there here, like this. Next, like that we have to think 2 1 is there, 1 1 is there, 2 1 is there. Okay, no problem. See here 2 1 is there, 1 1 is there, then 2 1 is there, 2 1 is there, no problem, like this. Next 3 2 is there, right? And 2 with 3 is there. Okay, x y y z, then x z, that means 3 comma 3 is there, like this, x z. Therefore okay, it is there like that. Next we have to think like different kind. 2 1 is there, 1 2 is there, 2 2 should be there, 2 2 is there, like this. 2 1 is there, 2 3 is there, 2 3 should be there, like this. 2 3 is there. See here 3. Okay, we have okay 3 2 and 2 3, 3 3 is there, like this, no problem. Next 2 1 1 2, 2 2 is there. Next 3 2 2 3, 3 3 is there. 1 3 3 3, 1 3 is there, like that. Okay, to become it is transitive, we have checked all the possibilities. Now see my dear students, so we have here actually okay, now it is 1 2 2 1 is there, 2 3 3 2 is there. Now 1 3 is there here, like okay, 1 3 we have added. Why we added that? Because 1 2 2 3 1 3 should be there. Now 1 3 is there, it becomes symmetric. 3 comma 1 should be there, like this. Now 3 comma 1 also added. Now 3 1 1 2, 3 2 is there. 3 1 1 1, 3 1 is there, right? 1 3 3 3 3 1, 1 1 is there. 1 3 3 3, 1 3 is there. Now actually they have given that 1 2 2 3. Now it is reflexive. Why it is reflexive? Okay, 1 1 2 2 3 3 is there, and it become symmetric. Symmetric means you see 1 2 is there, 2 1 is there. If 1 2 is there, 2 1 should be there. That's why it is symmetric. Now 2 3 is there, 3 2 is there, right? It is symmetric. And 1 3 is there, 3 1 is there. Now transitive. 1 2 2 3, 1 3 is there, right? And also 2 3 3 3, 2 3 is there. And 1 1 1 3, 1 3 is there. 3 1 1 2, okay, 3 2 is there. It is transitive. Now how many pairs you have added? 1 2 3 4 5 6 7. Now 7 pairs you have added such that it will become an equivalence relation, such that it becomes reflexive, symmetric and transitive. 7 pairs you have added such that it becomes an equivalence relation, right? See now here for x comma y, 8th problem, x comma y belongs to real numbers, x related to y. How the relation is given? X minus y plus root 2 is an irrational number. Then R is, they are telling option 1, equivalence relation. Number 2, symmetric. Number 3, transitive. Number 4, reflexive but not symmetric and transitive, right? But not symmetric and transitive. Let us see that how this problem will be answered like this, right? My dear students, you see, we have first reflexive. Let us check reflexive. What is reflexive actually? X related to x. That means x related to x means x minus x plus root 2 is an irrational number, right? This is x minus x plus root 2. That means what you are getting, x minus x is 0, root 2. This is now root 2 is an irrational number like this. This is an irrational number like this. That is true. Therefore, it is reflexive. That is true. Root 2 is an irrational number. Therefore, it is true. No doubt in it. Okay. Option 1 is correct. Like next, let us check symmetric. Like symmetric. If you check symmetric, right? What is symmetric? If x related to y, then we should prove that. Y related to x. If x related to y, then we should prove that y related to x, right? How we will be proving that? X related to y means, right, x minus y plus root 2 is an irrational number, right? This is an irrational. Now y related to x, that means we should prove using x minus y plus root 2 is an irrational means we should prove that y related to x. That means y minus x plus root 2 is an irrational. This also we should prove that an irrational number like this. Right, y minus x plus root 2, we should prove that it is an irrational number. Okay, given this is an irrational number, now we have to prove that. That means actually minus of x minus y plus root 2, okay, is an irrational number. We have to prove that. Suppose if I get x minus y, okay, as, right, minus root 2, okay, root 2, okay, if I get x minus y as root 2, there is a possibility where x comma y belongs to real numbers, right? X comma y belongs to real numbers. Now you see, my dear students, x minus y plus root 2 is an irrational number. This is given for us. Like if this is given, right, then what we will be having is now, right, fine, minus of x minus y plus root 2. That means x minus y can be root 2 is possible. Why it is possible? X minus y is equal to root 2 can be possible. Suppose I will take this 10 root 2 minus 9 root 2, right? This is equal to root 2. This is possible. When x minus y equal to root 2, then what I will be getting here, this equal to now x minus y plus root 2. That means root 2 plus root 2. This is an irrational number means now y related to x like this. That means y minus x plus root 2. That I have written as minus x minus y plus root 2. That means minus of root 2 plus root 2. This minus root 2 plus root 2. This becomes 0. 0 is not an irrational number. It is not an irrational number. Therefore, it is not satisfying symmetric. It is not satisfying symmetric. Right? Now we have, my dear students, transitive. If x related to y, y related to z, then x should related to z. That means x related to y means x minus y plus root 2 is irrational. Y related to z means y minus z plus root 2 is irrational. Right? I have taken this as equation number 1, this as equation number 2. Now I added these like 1 plus 2. This we added like this. This means minus y plus y is cancelled, and you have here x minus z plus root 2. Right? This, okay, however, an irrational plus irrational. This is irrational and this is irrational. Irrational plus irrational need not be an irrational number. Okay? Need not be an irrational, because root 2 is there. Minus root 2 is irrational. Minus root 2 plus root 2. Okay? Irrational plus irrational. Right? Need not be irrational. Therefore, it is not satisfying transitive. I think we can say that it is reflexive but not symmetric and transitive. Option 4 is correct. Right? Okay, now see, my dear student, ninth problem with what we have, let S is equal to set of all integers. This for a comma b belongs to S. R is defined by like this. A related to b if and only if modulus of a minus b less than 1. Then R is what they are asking, only reflexive, only symmetric, only transitive, D reflexive and symmetric. Let us try this problem, how we are going to do this, my dear students. Here A related to B. Now reflexive. Let us try first reflexive, whether it satisfies now reflexive or not. Let us try first here, right? Now see my dear students, reflexive. Reflexive means we should prove that A related to A, right? A related to A. That means here modulus of A minus A is less than 1. That means modulus of 0, that is 0. 0 less than 1. This is true. That means it is reflexive, no doubt in it. Next, second one, symmetric. Let us try symmetric. Right? Symmetric. Symmetric means what we will have here like this. Right? Symmetric means, my dear students, if A related to B, then B should related to A like this. A related to B, then B should related to A. Okay, A related to B means what they have given is modulus of A minus B is less than 1. Modulus of A minus B is less than 1. Now, B should related to A means modulus of B minus A, which also we can write as modulus of A minus B. Both are same. That is less than 1. Already it is given. Modulus of B minus A equal to modulus of A minus B. That is true, right? Because modulus of 2 minus 5 is equal to modulus of 5 minus 2, that equal to 3. Okay, that is true. Therefore, it is symmetric. No doubt in it. Okay, now we have got the options that it is reflexive and symmetric. Right? Therefore, we can conclude that it is reflexive and symmetric. We can easily say like this. Right? My dear students, this problem, 10th one, which of the following relations on Z is an equivalence relation? That means it should satisfy reflexive, symmetric and transitive. Now, they given 4 options. The first option is X related to R1. Okay, the relation name is R1. R1. Y. That means mod X is equal to mod Y. They have given that. Let us check reflexive, symmetric and transitive for this. First one, reflexive. Reflexive means X should related to X. That means we will have mod X is equal to mod X. That is true, however. Okay, therefore it satisfies reflexive. Next, symmetric. Right? Let us check symmetric now. Okay, if you check symmetric now. Symmetric means what? If X related to Y, then we should prove that Y related to X like this. X related to Y means mod X is equal to mod Y, right? That is true. Okay, this is given. This is given. Now Y related to X means we should prove that mod Y is equal to mod X. When mod X equal to mod Y, obviously mod Y is equal to mod X we are going to get. That means it is symmetric, no doubt in it. Next, transitive, right? Transitive if you take, right? Transitive means what? If X related to Y, Y related to Z, then X related to Z like this, right? Here X related to Y means what we have here, mod X is equal to mod Y, right? And Y related to Z means what we have here, mod Y equal to mod Z then. Right? Now X related to Z we have to prove. That means mod X is equal to, from the given thing, mod Y equal to mod Z means. That means mod X is equal to mod Z is true. Right? That means X is related to Z. Right? Okay? That is true. That means X is related to Z. That means it is transitive. Therefore, the first option itself is correct. It is an equivalence relation. Right? It is an equivalence relation. Next, for conceptual purpose, let us check with second, third and fourth also. Second one, what they have given, X related to Y means X is greater than or equal to Y. Let us check first reflexive. Reflexive means what, Nana? X should related to X. That means X is greater than or equal to X. This is true. Okay. X 2 is greater than or equal to 2 because equal symbol is there. That's why it is satisfying. Next, symmetric. Right? Symmetric if you take here. If X related to Y, X related to Y means what? X is greater than or equal to Y. Then we should prove that Y related to X. That means we should prove that Y greater than or equal to X. Whenever X greater than or equal to Y, Y cannot be greater than or equal to X. Always it is not true. Therefore it is not satisfying. Therefore it is not symmetric. And if you check even for conceptual purpose, transitive, right? X related to Y is given, Y related to Z is given, then we should prove X related to Z for this, right? This is what transitive. How we will prove? That means X related to Y means X is greater than or equal to Y, right? And you have here, right, my dear students, y related to z means y is greater than or equal to z. Okay, now you know that by given things x is greater than or equal to y and y is greater than or equal to z, we can say that x is greater than or equal to z. That means x is related to z like this. X is related, therefore it become transitive. Nicely we have got. Therefore the second one is, it is reflexive but not symmetric, but it is transitive like this. For conceptual purpose we can discuss like this. Now the third one, x related to y, means x divides y. This is what x divides y. Okay, the meaning is here x divides y. This is what the meaning of. Now let us check this reflexive. First reflexive, x related to x, that means x divides x. Yes, every number will divide itself. That means it is true. Reflexive is true. Next symmetric, let us take symmetric now. Symmetric, let us check what we have to prove. If x is related to y, then we should prove that y related to x. That means if x divides y, then y divides x. Is it true? No. If 2 divides 4, can we say that 4 divides 2? No. Therefore, it is not satisfying symmetric. Next, transitive. Okay, transitive, you know that. Let us write directly. If x divides y and y divides z, then x divides z. X related to y, y related to z. Then we should prove that x related to z like that. Okay, here 2 divides 4, 4 divides 8, then 2 divides 8. This is always true like this. X divides y, y divides z, then x will divide z. That is true always. Therefore, it becomes transitive. Right? Now, the third one, the third relation what we got is, it is reflexive and transitive but not symmetric. Right? Now, the fourth one, my dear students, we have x related to y. That means x is less than y. Okay, reflexive. To check this is reflexive. Okay, x related to x, that means x is less than x. Any number will be less than itself is wrong in mathematics. That's why it is not satisfying reflexive. Next you take symmetric. Next we take here what? Symmetric. Like symmetric means what? If x related to y, okay, then we should prove that y related to x. That means if x less than y, can you say that then y less than x? Wrong, wrong. If x less, if 2 less than 4, then can you say that 4 is less than 2? That is wrong. Therefore, it is not satisfying symmetric. Next, transitive, right? Transitive, right, Nana? See the transitive, how you will be proving this is right. If x is related to y, y related to z, then we should prove that x related to z. That means x is less than y, y is less than z, then we should prove that x is less than z. That is true. 2 less than 3, 3 less than 5, then 2 less than 5. That is obviously correct. Therefore, here this one is satisfying, my dear students. Here it is not satisfying reflexive, it is not satisfying symmetric, and it is satisfying transitive. Right? Like this, we have some different kinds of problems. This is the concept. Once you understand, you try, you take a pen and paper and try, you will get different problems. Thank you very much. Thank you.